In today's video is going to be an absolute beginner's guide to building a quadcopter. It's going to be very fast, full of information, and efficient build, and help you understand why things connect where they are and why am I using the current components that I'm using here. Now, this is considered a high-end build or a premium build, actually a mid-range. It's a premium build, but the price is sort of mid-range-ish here. So we're going to cover how to install everything, what everything is, the proper terminology, and also give you some pointers and tips on how to solder and what to look out for and things not to do. For example, like soldering a wire over the ESC or some kind of a board, because the solder could just drop and you might never see it because it's so tiny and cause a short and your whole thing catches fire. So you got to be very careful. So let's talk about the tools, then we're going to talk about the components, then we're going to go ahead and start building here. Now for tools, what I highly recommend for anyone getting into drones would be this right here. This is the RJX interchangeable hex driver toolkit, which is also titanium here. So these come with every single size that you'll ever need for any drone, because most of our FPV drones, whether it's a micro like this or a big one like that, will use 1.5 millimeter, 2 millimeter, 2.5, and 3 millimeter. And this kit comes with everything. Now you'll also need a cutter for wires. So yeah, you'll just need that, and a soldering iron and some tweezers. That's basically it. Now for soldering iron, I'd highly recommend you pick up the TS100 if you don't have a soldering iron. But if you do have a dedicated soldering iron, I'd still highly recommend you pick this up, because this is what I take with me to the field. And I've had this, I think, for 2 years now. And when these first came out, they were $100, I think, something of that, $90. Now they're like $40, and you can plug in any battery you want, anywhere between 12 and 24 volts. So that is insane. It's very portable, and it's the best portable soldering iron on the planet. And everybody would stand by that, because you could use this as your main lead driver. You don't even have to buy a dedicated soldering iron. And again, highly recommended, and it'll be linked down below. Everything here is linked down below. So now for the ESC, let's start with the ESC for the component. Now we're using the Holley Tekko32 40 amp ESC. This is their low cost one, but it doesn't mean it's terrible. This is premium ESC at a good price, around $52 right now. And it's highly recommended because it performed absolutely spectacular on my noise testing, which is my lab testing, and that's why I'm putting it on a 6S very power hungry build here. So that's for the ESC, and again, everything is linked down below. For the flight controller, we're using the latest F7 Holley Hakcrc V1.5. This has everything: OSD, barometer, SD card expansion, the big F7 with the more memory and the more RAM. We also have our soft mounted gyro. This actually works really, really great here. So overall, this is a proper flight controller. And again, it's using the latest compatible processor that we could find on the market for our Betaflight flight controllers here. Next, let's talk about the VTX. Now, if you don't know what a VTX is, it's a video transmitter. What I'm going to be using is the Rush Tank Ultimate Mini. These are a beast of a VTXs. If you are unsure what to get and you wanted something that's from a well-known brand that a lot of people use, Rush FPV is the place to go. This is a really nice VTX, plus it's small and compact. It'll fit anywhere. I'm just going to double side tape that right in the back here. And it has something called Smart Audio, which we'll cover later on. Now for camera, I'm using an FXT Mars Pro. These are pretty expensive cameras. I really love the quality more than anything on these. And to be honest, I don't have any more run cams or Fox ears. And I've had this for a very long time, which I've done latency testing on. And it's really fast, and I really love the image quality, and it'll fit on this frame. But you can choose any other camera you want. I'll have some great ones linked down below in the camera section. So I'll have a section for everything. So you can choose another camera if you wanted to at a cheaper price. Next, for the receiver, since I'm using an FR Sky transmitter, I'm using an XM Plus radio, which I'll have linked down below. These are really great radios. They get hella long distance, 3.4 kilometers of distance. So that's what I've gotten on a wing before on this guy. So these are really, really great, really cheap, also $10, and they're really small. So that just, it just checks all the boxes there. That's why I really love these XM Pluses. For frame, we're using an iFly XL 5V something. I lost track. This is their latest revision from the XL5. It's a beast of a frame. Stock Betaflight PIDs most of the time would get you going perfect. You wouldn't need to do much tuning. And if you follow along with me, I'll also release the PIDs once I take it out flying. So I'll have this one linked down below. It comes with a bunch of 3D printed parts to hold your antenna and everything, which we'll take a closer look at once we get to that stage. Now for the motors, I'm using the new Racer Star SICK 2207 low kV. Well, they're low high kV. So they're 1888. So these tested really efficient and really nice on my thrust test, and I've done the review on these. They looked really great, and I couldn't wait to put them on a build, and it's going to be this setup. So right now we're going to be testing these motors with this new stack basically in my upcoming videos, and that's why we're doing this build together. So, and again, everything is linked down below, and let's get started. All right, so the first thing I always like to do when I approach a build is prepare all the wires. And for example, here's the camera wires, which I've prepared. I've just stripped, I've twisted them, and I've added solder to them. I've done that to every single wire that I'm going to be connecting. Here's the camera wire. Here's our receivers wires right there, and also our VTX wires. As you can tell, I've done the same thing, stripped, twisted. The twisting is very important, and then soldered. This will make the overall process so much quicker and so much simple to do. Now, another great feature with the Hakcrc here, the flight controller, well, the stack, if you purchase the ESC with the flight controller here, is that you're not going to have to worry about the connections between the ESC and the flight controller, because it does come with a connector. We're just going to use that and then connect to the ESC, and everything will be routed for us. So that's really nice. So all we're really going to have to solder is just this stuff right here, which is really simple, and also the motors to the ESC, and we would be basically done. So let's get started. Now, the first step I always like to do is grab my flight controller and start soldering all the little wires that are going to be going to it. For example, here's our camera wire. So let's start with the camera wire. So on this flight controller, the camera is going to be connected up here. We have the G, which is going to be ground, which is black wire. 5 volt is the red wire, which is the power. And VI is the video input, which is going to be the yellow wire. So let's go ahead and do that. All right, so we're going to go ahead and start with these. I like to start by adding solder first. However, you need to take something into consideration with this board. It has conformal coating on there, which makes it water resistant. Out of the manufacturer here, as you can tell by the color, it does have conformal coating to make it water resistant. Not waterproof, water resistant. So sometimes you might have to hold the soldering iron just slightly more in order for the to get the solder to stick here. Just keep that in mind. That's not always the case, but it's good to know for a future build of yours, because some companies do actually do that. So right now I'm going to start adding solder to the pads here, and I'll just wait for it. Now, always the ground will always be the hardest to solder to, and you might be like, why is that? Well, because the ground is always connected to the whole board. Like, there's just really big copper traces inside, so it takes a while to heat up everything, because the inner part of the ground would act as a heat sink and kind of dissipate that heat. As you can tell how easy these two were and how hard. It wasn't that hard, but you could notice the time difference that it took me to get the ground to stick here. So right now we have the solder into place. I'm going to go ahead and grab my wire. Now, something very important to take note of. If you're right-handed, start from the left and move to the right. Because if you were to start from here and then you move here, you have a higher probability of bumping into the previous wire that you've done. And this is a really great technique to use. And another thing that's very important, make sure you're comfortable. You've rested your forearms on the edge of the table. Get it how exactly you need it. And then just once you're ready, go ahead and go in for the kill. And what I like to do first usually is I would heat up the pad, lift up the soldering iron, and then retouch it again once the wire is into place here. Now, I really don't like how this one's coming out. Maybe it needs a little bit more solder. There we go, that's nice. Okay, so that's our video line, which is obviously the video input. So now it's going to be the 5 volt. There we go. I'm making sure I'm hitting it longer than usual because of the conformal coating, because sometimes it actually won't make a connection even though the solder is on there. That's happened to me twice before, because I made a couple waterproof quadcopter or water resistant quadcopters before, and it's just something to take note of here. You might think it's not working, go purchase another thing, but sometimes just resolder the things, and things do magically sometimes just end up working. So that could save you some money and hopefully save you a headache. So now we have our camera wire into place here. Let's go ahead and do our receiver. Now, what's really nice about the F7s here, the F7s don't care whether you have an I-bus receiver or S-bus receiver or a Spectrum receiver, because it'll understand it on every pad. However, for example, if this was an F4, then an S-bus has to go to a specific pad. And we're not going to get too far into that because this is an F7 right now. So let's go ahead and set this up. Now, my receiver is going to need 5 volt ground and the signal. So the signal is going to tell the flight controller what to do when I give the command. And where the signal would go on any receiver is an R pad. So consider as the R and the T pads as USBs to the flight controller. So let's go ahead and find where this one goes. So we're going to put this on R6. So we're going to call it USB 6. Make sure it's on R, and the R, what the R stands for is receive, because the flight controller is going to receive data from our receiver to tell it to turn right when we tell it to turn right. T that's on here would be to transmit data, for the flight controller to transmit data to something. And we'll cover a T later on because we're going to need one. So let's go ahead and start again by adding some solder to the ports that we're going to need here. So we're going to start with the ground again. As you can tell, it's right there, and it's going to take a little bit longer. There we go. And then here's 5 volt right there, because mine takes 5 volt. And here's, I think this is R6. I can't see from far away. I'll just double check that now. Yes. Okay, that's perfect. Now, what I want to do is, for some reason, I get a feeling like the ground didn't really stick very well because of the conformal coating. So I'm just going to just do this a little bit to it. Make sure these do have enough solder on them and they penetrated or melted away that conformal coating layer. All right, and now I'm going to grab my receiver's wires, and it's the same process. I'm going to start from the left because I'm right-handed. So the R is going to be our signal, and my signal for the S bus is this yellow wire. All right, so that one's in. Next is going to be the 5 volt. Maybe I should have trimmed these down a little bit more, but it's okay for now. Here we go. All right, and I'm actually making it through the hole here. So after a while of practice, you can get it to go through the hole, but you don't really need to have it go through the hole. And that's what she said. All right, and like this, now we have our receiver. We're almost done. It's really that simple. So the next thing we need, or the only thing we have left now that goes to the flight controller, is our video transmitter here. Now, our video transmitter usually takes 3 wires, but we're going to do 4 wires because of something called smart audio. Now, smart audio, what will that allow you to do is change the channel, the output power, and everything of the video transmitter without having to come to the quad and change the channels through here. So you'll be able to do that through something called the on-screen display, which is the OSD, which we'll cover in a later step once we get to that. So right now we need power. Now, this VTX takes 7 to 26 volts or more than that. So it's considered a battery voltage VTX. Now there's 2 types of VTXs usually, a 5 volt and something that I call battery voltage. And how do you know that? The battery voltage VTX would say on the specifications that it takes 7 volts and above. What that means is you have to give it battery voltage. Now if it was a 5 volt VTX, then you'd have to find a 5 volt pad to give it the red wire for that. But again, this is battery voltage. And what's really nice with this flight controller here is they actually have a dedicated pad right for the battery voltage here. So that gets routed through the connector from the ESC and it gives us battery voltage right here. So that's going to be great. So that's where we're going to put our red wire. And then the next one over is going to be ground. And then this one is video output, which is going to be our yellow line, because the video input goes here, goes through the on-screen display chip, and then pops out to the video output. And then we're going to find T1 where we're going to install the smart audio. Now, why is it a T and not an R? Well, because we need the flight controller to transmit data to tell the video transmitter what channel to be on. So that's why we need a T pad for the smart audio. So let's start adding solder to these guys right now. So another tip is to make sure your soldering iron tip is always this shiny. If it's not, add a little solder, clean it off, and then come back in for the soldering, because this way it'll make everything so much easier for you. So here's the B+, which is going to be the battery voltage. Make sure I heat that up really nicely. Here's the ground, and again, as you can tell how it's taking a while for it to melt there. Then we have the video output, which is going to be our yellow wire. And then we have T1. You don't want to hold it too long on these holes, or else the solder would fall to the other side. So here's an example, you can see that. Now if that does happen, just come back to the other side, hold the soldering iron on there, and let gravity do the work for you here. And there we go, we kind of got it into place here. I'd prefer to add just a little bit of more solder to this one. And as you can tell now, I'm lifting up faster to keep the solder up top here. So let's grab our video transmitter wires now. And again, I'm going to start from the left and move to the right because I'm right-handed. I'll start with the top one because that would be the most difficult later. But it's going to be the easiest right now. So I'm just heating up the pad and kind of guiding the wire through the hole, but you don't have to guide it through the hole. You can just put it right on top. Next thing, we have the ground wire here. So let's go ahead and do that as well. As you can tell, I don't have to put it through the hole. And this one I'm not. I'm just going to set it up like this. That's going to be totally fine. Next here we have the video output, which is going to be our yellow line. So let's go ahead and set that up. Very nice. Make sure there's no strands of the wire sticking anywhere, or else you'll have a really bad time. You can have a really bad short circuit. There's our smart audio on T1. Now take note of T1 because that number is going to play a big role when we program this into Betaflight to tell it where the smart audio is, so the flight controller knows where to speak. So as you can tell right now, we're basically like 60% complete with our build. It's really that simple now. It's been always like this actually. So let's put this to the side and let's see what's our next step. All right guys, so the next step right now is to install your motor wires as well as your ESC into the frame. Now, once that's done, what I recommend you do is you run the motor wires and add 2 zip ties right here, or 1 depending on your frame. If you're using this, I'd recommend you use 2. And don't tighten these too hard. These are actually pretty loose, but I just kept them here so I can figure out how much wire I'm going to need to cut off to have a really nice clean build. As you can tell here, it's going to be really nice, and that's what I've done here. So I've cut all the wires to length and twisted them and added solder to them. So once you get that step out of the way, then you're ready to start installing it into the ESC. So let's go ahead and do that. So when you're installing your ESC in, you need to take something into consideration. Where is the front of the quadcopter? Currently our front is right here. And how do I know this? This is from the camera plate, so obviously the camera is always in the front. This ESC has an arrow, but some ESCs do not have an arrow, and it's very important to install this correctly no matter what 4-in-1 ESC you're using because of the motor orientation. Now this is considered motor 1, and then this is motor 2, motor 3, and motor 4. This is default beta flight. You'll learn it as time goes on. You don't need to memorize it. I've built over 50 quads, so I had to memorize this. So motor 1, 2, 3, and 4. This is the front, and usually all 4-in-1 ESCs have the numbers on them. So we can see motor 1, 2, 3, 4. So that's perfect. And again, it has an arrow, so that really does help. So the next step here, again, is to go ahead and start by adding some solder to the ESC. So let's go ahead and do that together here. Now this can be kind of tricky at times, so make sure you're really comfortable and you're really going to be able to just keep your hand steady. So don't rush anything. So right now what I'm going to do, as you can tell, I'm just heating up the pad, and then I'll bring in the solder around the place, and then just make sure that pad is getting really nice. There we go. We want it to kind of stick up like a really nice, beautiful, shiny ball. That means you're doing it right. There we go. Now, I also noticed with my assistant with teaching him how to solder these ESCs is that he's afraid to keep it on for very long. But no, these boards could handle a lot of heat, and you need to have a really good connection in order to have the best power delivery when you install your motors. So it's okay to keep the heat on there for a while. As you can tell how I'm doing that. This way I'm making sure the whole pad is warm. Okay, this one's a little bit hard to see for me because it's behind the standoff here. So now I'm going to turn the ESC around. The reason for that is I don't want my soldering iron to be over any of these components here. So this way I could just come in and then just go out this way. So it's very simple for me. And again, we're going to do that same thing. As you can tell, wait for it to melt all over the place. All right, that is awesome. And if you see these little dots or these little balls like this splatter around, that's fine. That's flux. It's not solder, so the camera might make it seem like it's solder, but it's actually not. There we go. As you can tell, you want them as shiny as possible. Okay, really nice. And hopefully you learned this technique from this video here. Okay, awesome. So now we have these set into place. Now we also need to add on our power pads here. Now if you do have standoffs in the way, don't be lazy and just remove the standoffs, so you make your life so much easier if you go ahead and do that. As you can tell, one of the standoffs is actually a bit too tight, so I'm going to go ahead and use my hex driver. And the reason why you'd want to use these more than Allen keys is one, they don't strip out your screws, because if these screws get stripped, because sometimes you're going to have to apply a lot of pressure, and if one of the screw gets stuck in there, you could ruin the whole frame, and that can be an absolute nightmare. It's just devastating. So the power here is usually the hardest part, and you can tell if someone is a pretty experienced builder or not from the power leads here, because this is the hardest part to get solder on, especially the ground, because this is going to have so much copper inside it, it's going to dissipate the heat all over and take forever to heat up. Now, and again, I use the same technique. Right now I'm soldering at 450 degrees Celsius, not Fahrenheit, Celsius. Look at that. It's just already, it's just coming back. It's not even melting. Like, I can't move it because, so look how hard it is for me to actually melt this. It takes some time to apply the heat. Sometimes you might want to go ahead and add a little bit of more heat. So, and again, I'm soldering at 405 degrees Celsius, which is pretty high actually. But this is what you need to do. The positive will always be slightly easier. And again, I'm using the same technique we used for the motors there. So there we go. You need to be careful not to go on the bottom side, have it drop. I'm just making sure this is really nice. Awesome. So we have that all set and done. Now, let's start with the motors, then we'll move to the ESC power. So some people usually get lost. They say, oh, which motor goes to which pad? Well, the most important thing to know is that each three will take one motor. So these three will be to this motor, these three will be to that motor, and I just burned the shit out of my hand. And, you know, that's the most important part. It doesn't matter the orientation you put it in, and then later on we could change it in the software, which we'll get into in a later step. So right now I'm going to try to make it as clean as possible. So I'm going to take the last wire and I'm going to install it here. Now, a really nice way to do this is what I like to do is I like to come in, I like to heat up the pad first and make sure you guys can see everything. I like to heat up the pad. I'm actually going to remove this standoff just to make it easier. And always don't half-ass this because these are really expensive components here. So have your hand ready, which you'll be able to apply pressure to, as you can tell, just like that. So I'm just going to heat up the pad. Then I'm just going to bring in the wire and then hold the wire on top, wait for it to melt. Make sure I keep applying my pressure. Try not to move it, and boom, we have our first wire. And we'll do that again so you guys can see that. And usually just seeing the technique really makes a big difference. Like every time I see a new technique that I like, I try it out and usually works out really great. And this is the idea here. I'm trying to give you guys as much info as possible and help you be better builders and give you techniques, especially if you're new to this stuff here. All right, so that's good. I'm just gonna push these down now. Now you need to double check if they're touching or not. Now this thing is really, really far away from me, so I can't see, but that's looking absolutely awesome. I don't know how it's looking on the camera because I have a really small screen that I'm looking at right now. So, and again, I'm gonna do the same technique here. We'll do just this motor together so you guys get a better idea. Make sure you're not going to be touching anything. Now this is very bad. Look how I'm coming in from on top of the ESC. You never really want to do that. And another thing you never really want to do is let go of the wire when it gets really hot, because the solder is still melted and then it'll just splatter everywhere. You could ruin your whole ESC without even turning it on, because cleaning that is an absolute nightmare that sometimes, you know, I can't even clean. And that's happened to me before. So just keep that in mind. Use some tweezers. It'll make your life a lot easier. And if you're holding tweezers, you want to hold it like this so you can apply pressure down like that. As you can tell, look how I'm doing that. Like that. That's how you want to hold these tweezers. You don't want to hold them upwards because it just doesn't really help that much. So there we go. You want to hold it to as close to the edge as possible. There we go. We start heating up our pad. Make sure it's nice and toasty. And then we bring in our wire. You hear that beautiful sound. Hopefully you guys could hear that beautiful sound. There we go. This one wasn't the cleanest ever, but that's fine. I could live with that. Some of you probably won't. So what do you guys think of the FRSky thing? If any of the veterans are here right now. Also, come join my Patreon. I just gave away SkyZone OLEDs and a brand new FRSky X9D and one of my Flywoo builds, like a proper 6S build. This one's going to be up for a giveaway soon to my Patreon as well. So come join my Patreon. Don't miss out. I do a ton of giveaways every month, not just one or two. All right, so this side is complete now, as you can tell. And I'm going to skip over the rest and we'll come back and see what's the next step. All right, guys, so now the next step here is we want to start with our power, our main power, where the battery will be connected, and our XT60, which is this little one right here. However, we're also going to add the low ESR capacitor that was provided with this ESC, and I highly recommend you do. What we're going to do is we need to find the negative part here, and that's going to go to the negative side of the pad right there. So this is the negative and this is the positive. So ground, positive, and this is where the ground is. Positive usually has nothing like that. So what I want to do first is I want to install this into place here, and we're going to heat up the ground again. The ground's going to take some time to heat up, like I told you, because it's usually the hardest, especially on massive premium ESCs like this. That means the heat dissipation is good, and as well as the power delivery. So right there, we've got that into place. It's not clean, but that's totally fine, because now after that, you can see how the positive quickly melted. Because after that, so that's fine that it's not clean over there, because we're going to need to put our wire on top of it. Now it's very important to actually know how you're going to be setting up the XT60. Now I'm going to 3D print a part that I do to all my quads, especially for top mount batteries, which is this part right here. So this is a really nice 3D printed part. I'll have linked down below. It just goes to one of the standoffs and it'll hold your XT60, and this way it reduces the chances of it getting cut anywhere. So I really like this, and there's a standoff here, so that's what's going to happen. So I'm going to have my XT60 come that way. Also, another very important or a great hint or tip is to try to get these as short as possible. Not too short, but if there's some extra slack, like for example, this is a big no-no here. You see that? That's very bad. That could introduce a lot of noise and some unwanted behaviors that, otherwise you probably wouldn't be able to fix or even know where it's coming from. So always try to keep very short power cables here. Now, I want this to pop out to the left here, so let's see what would be easier. I think it would be easier for me to solder the ground first. So I'm going to solder this ground first here, like this. And the screw just came off, but that's fine. All right. So now and again, I'm going to heat up the pad. This is going to be slightly harder. I might want to increase my temperature to possibly 450 degrees Celsius now, just to make my life easier. There we go, 451. So I'm waiting for that to heat up. And anyways, we'll try to attempt it while that's heating up. So we'll preheat the board basically like this. As you can tell, it's taking some time. And there we go. We can see that went perfect. Now we're going to have to melt this big wire over it, and that's also going to take some time. To also speed up the process, keep pressure on the wire like I am, and then bring in the solder here. And that will allow the heat to transfer much quickly and much better, and also give us an overall better connection here. See, that was a huge fuck up right there. Good thing this ESC doesn't have any close components, or we could have screwed a bunch of things up. So here's that. I think that's going to be really nice. There we go. Yeah, that looks great. So just making sure everything's inside. Everything's looking good so far. All right, now we're going to do the positive. The positive side is going to be much easier. And we still also would want to add some solder to as well, just to give us, a better connection here, because it does also give us a little bit of flux in there. So I'm keeping pressure with the soldering iron. I'm not putting too much solder. Then when I'm ready, I come in with the tweezers, hold it into place, try not to move it, and wait for it to dry. These take a little bit longer to dry, so try not to move it for a while. And there we go. Now we have our power. Now we need to make sure that they're not touching, and nothing is touching here, so that's really beautiful. Also make sure the capacitor is connected correctly, and it is. And also something very important, quickly go decrease the temperature on your soldering iron, or else it'll go black and get oxidized, and it turns into a piece of crap then. So this stage is currently complete now. I'm going to go ahead and bring in my standoffs that I've taken off. I did melt this one slightly, but if I push it hard enough, I should get it to work again. We'll come back to that later. So if you ever melted your standoff like this here, it'll still work. You just need to cut just a little bit off of it, just to the top off. Not too much. There we go. And that'll do just fine. Now it's like brand new again. There we go. So you got your standoff back into place. You don't have to take the whole thing apart and try to do that. Here it's also melted slightly, and it's just becoming a little bit difficult. And again, I'm just going to trim a little bit off of that, and then bring in my other standoff and go ahead and twist this guy, and I should be good. So here's another tip for you. So instead of wasting them, because that'll hold still pretty perfect here. All right, so now it's starting to look really nice here. Now let's go ahead and grab our flight controller. We also need our wires that come with the flight controller, which I need to go look for because I don't know where the hell I put them. Give me a second and I'll be back. All right, so I found the connectors. Now this flight controller gives you two connectors. It has this really long one and a really short one. We're gonna use the short one. We don't need the long one for anything. So right now we're gonna bring in our flight controller here. So let's get a closer look at what I'm doing. We need to find the arrow again, point that forward, kind of like what the ESC is doing here. I'm just gonna bring these nice and easy, and we're just gonna put them into place here. Okay, there we go. Nice and gently, don't force it. You could bend these standoffs here because they are plastic, but don't force the flight controller too much. There we go. And now, as you can tell, here's the connector. And actually the connector isn't going to go, so we are going to need the longer one. For some reason, I thought they were connected into the same orientation here. So, all right, there we go. So I got the ESC connector into place. I'm going to twist this slightly. I like twisting these wires because they're silicone, and it'll give us a better connection overall. And I don't want anything sticking out too much. There we go. We could just wrap it down here. Very nice. Okay, so now we have our ESC connected to the flight controller. Very simple connections going from there all the way to that. And here's our camera, which we're going to leave for a bit. Now we're going to get our video transmitter. Now the video transmitter I will be placing down here. So I'm going to use double-sided tape to hold that into place. For this receiver, I'm going to add some tape around it once I bind it. And what's really nice is with this frame is they give you the 3D printed part, which I need to find, which is this here. This is really nice because it holds your SMA for your VTX, and at the same time it has a little pouch you can use to put the receiver into place, which I'll show you what I mean in a bit here. But right now what I want to do is I want to go ahead and grab some double-sided tape before I go any further. So now we have our video transmitter into place with the double-sided tape under the low ESR capacitor here. Okay, there we go. Now what's next? Now we have our receiver. We're going to keep that for a little bit later. We're going to bring in our 3D printed part here. That's going to go right up here. But first, what I want to do is I actually want to set the receiver backwards here. So now we bring in our 3D printed part. So this is going to go in right there. And the receiver is supposed to be, it's not supposed to be, but it'll be nice if it's mounted in there. And that's what we're going to do. But common sense might tell you to do it backwards like this. And yeah, that is the case if you have those plastic things that go out here. However, I don't, so I'm going to do it a little bit differently. And you'll see what I mean by that. So I'm going to bring it in backwards. So it's going to point towards the front of the quadcopter. And I'll show you my reason for that. And then we're going to go ahead and bring in this 3D printed part and just install it into the standoff. It's TPU, it's flexible, so it's really nice into that perspective. And now these receiver antennas, what I'm going to do is I'm going to move one to each side here. So I'm going to move one down here and the other one to the other side. And we're going to actually set these up like this with zip ties. That'll be pointing like that. So it's going to be pretty awesome. You'll see what I mean in a bit. So this is done, set into place. Let's go ahead and bring in our camera. So here's our camera and here are our side plates. I'm just going to quickly install the camera into the side plates and then we can continue connecting the camera and seeing what's the next steps after that. All right, guys, and this is complete right now. Look how clean it came out. Let's actually zoom in here. So everything is all good. All I need to do is add some tape around this and remove these zip ties before I go fly. Make sure nothing touches the gyro up there. So that part right there, nothing is touching that. You want to keep that clear. And also, as you can tell, the receiver's antenna, this is how I routed them through these heat shrinks. Different colors because I just ruined one of the yellows and I can't find the rest of them. So I just used the green and the yellow. That's totally fine for now. I'm also going to 3D design and print that thing that's going to hold the XT60 because that will get cut off in midair. So that's the only problem with top mount battery frames sometimes. And this is what I've done here on my favorite build. As you can tell, it's really fast to print this little thing. It just goes to the standoff and it holds the XT60 really, really nicely, and it's a must-have. This is my favorite quadcopter. That's a Basher. It's like $150 quadcopter I built. This one's going to be a bit more premium, obviously. Titanium shaft motors. This is going to be just an absolute beast in the air, and as you can tell, just everything looks nice. Here's the video transmitter back here, and it's connected with the MMCX right there. I don't know why it's not focusing. There we go. So it's connected with the MMCX to this right here, and these are held into place right there, so you can see that over there. And the camera, again, FXT. Maybe I might lift it up a little bit more. It is a mini, so keep that in mind. It does this frame does take micro cameras and mini cameras. If you're using a micro, they give you these 3D printed parts, so you can have the offset inside. And overall, I think this came out really, really clean. Very satisfied with it. Now this will be possibly the end of October Patreon giveaway, so come join my Patreon, and I do more than one giveaway per month, so you have a high probability of winning. And I'll also have linked down below the cheaper variations of some of these components in order to reduce your cost down somewhat if you really wanted to build a pretty sick ass quadcopter. Now this is a 6S build. It's going to be a monster, and the video should be out within the next 2 days of me flying it and giving you my overall feedback, PIDs, and everything else you might want to know. And I'll see you in the next one, guys. Peace out.